These are the solutions to Checkpoint Quiz Module 1. So this 27 to 1/3 is nothing else but the cube root of 27, or even better, you replace 27 by 3 cubed, you copy the base, multiply 3 by 1/3, you get 1, so the answer is 3. Same thing here. I replace 16 by 2 to the 4th, same idea. Copy the base, multiply. This is negative 20 over 2, which is negative 10, which has to be written as 1 divided by 20. Negative exponent. Here we have two exponential notations to multiply. They do not have special power, so I will multiply 3 by 4 and get 12. And when I multiply these two, I copy the base and add the exponents. We cannot add fractions if they don't have the same denominator. The least common denominator must be 12. The numerator of the first fraction has to be multiplied by 4 because 3 was multiplied by 4. The numerator has to get a 4. 4 was multiplied by 3, so the numerator has to be multiplied by 3. 4 times 2 is 8, 3 times 3 is 9, 8 plus 9 is 17. As you know, this is nothing else but the 12th root of x to the 17th, which has to be presented as 12 and 5 because of the index is 12. The 12th root of x to the 12th will be x, and then the 12th root of x to the 5th is just that. Here we simplify by 9 and we get 8. Copy the base, subtract the exponents. 3 over 4 minus 1 over 3. The same thing, the least common denominator is required. We multiply the top by 3, the top by 4. So 9 minus 4 is 5. Here, the numerator is smaller than the denominator, so there is no need, and I cannot simplify like I did here when the numerator was higher than the denominator. So that's it. It's the 12th root of x to the 5th. That was section P.3. P.5, we're asked to factor. It's factoring by grouping. We factor out x squared, x minus 1. And then the same thing from the other two. Now this is the common factor coming out, and that's x squared minus 5. I explained this in the readiness quiz. We multiply the first and the last term as in descending order, of course, and we get a product of -6, and the sum is always 5, always the middle coefficient. So we need to find two numbers whose product is -6 and whose sum is 5, and those numbers are only 6 and -1. We will replace 5x by 6x minus 1, 6x minus 1, and then we factor by grouping as we just did up here. So 2x, x plus 3, we factor on -1. Now then the common factor is x plus 3, and then 2x minus 1. Same thing, we had an example in the readiness quiz. Difference of squares, 6x minus 7y and 6x plus 7y. In any order you like, it doesn't matter. Same thing here. First term squared plus 2 times the first times the second plus the second term squared. This is the binomial squared. 5x plus 1. Always check the middle term. The middle term in this expansion is 2 multiplied by 5x multiplied by 1. Since this is 10x, that is the correct factor form. Next question, we only had 1.1. We were asked to determine some percentage when n was 24. So n equals 0 represents 1990. 2014 is exactly 24 years later, and we plug it in and we get 66.4%, and the graph gives us this. Section 1.2, we're solving linear equations. This was exactly the same problem on the readiness quiz, so we can go back there. This is a rational expression, a rational equation. So I recommend the following method. You can use others, of course. I will move one term to the other side. It's positive, it becomes negative, and the right-hand side becomes 0. This has to be an equation. Left-hand side equal symbol, and right-hand side. Here I find the least common denominator. Don't forget to write these restrictions, mandatory. X cannot be -5, x cannot be 5. So, of course, like before, the least common denominator is the product of these two factors, and x plus 5 was multiplied by x minus 5. So the numerator has to also be multiplied by x minus 5, and the same thing, the opposite here. It has x minus 5, it doesn't have x plus 5. So 4 times x, 4x, -20, plus 2x, plus 10, minus 32. Combine like terms, and we get 6x minus 42 is equals 0 over 1. Now we cross multiply. 6x minus 42 times 1 equals 0. Again, there are other methods. I strongly recommend this method. So we get x equals 7. Is that okay? Yes, because it's not on the list of restrictions. So here we read from a graph. In 1.5, this is a radical equation. I'm sorry, this is a quadratic equation, and we take the square root from both sides. The left-hand side is x minus 1. Don't forget plus or minus. The square root of negative 9 is 3i. We move 1 to the other side, and we get the answer. Here we're asked to use completing the square. So the method says descending order, middle coefficient, negative 2 divided by 2 is negative 1 squared, and 1. We get 1. This is the number we add to both sides, and of course I move negative 5 to the other side. This is the factor form x minus 1 squared, a binomial squared. And then 5 plus 1 is 6. We take the square root. Don't forget plus or minus. It's a quadratic equation, 2 solutions. Move 1, and we get the answer. On the next problem, we're asked to use the quadratic formula, negative b plus or minus b squared minus 4a, square root of b squared minus 4ac over 2a, and we identify the coefficients, we plug them in correctly. The discriminant is only obtained only after we set the equation in descending order equal to 0. And this is it, b squared minus 4ac. So b squared is 4 minus 4ac is negative 12. This is a negative number, which means 2 imaginary solutions. Here we're given a garden with the length 3 yards longer than the width and the area of 180. So y equals x plus 3. I replaced it in here. So x times x plus 3 equals 180. I created the equation moving 180 to the other side, set equal to 0, quadratic formula. I obtained x equals negative 15, not possible. We're talking about distance. So then x equals 12. And then go back, check, and find y. Radical equation in 1.6, we square both sides. Remember, binomial squared 3 terms. The left-hand side is x plus 10. We combine like terms, moving all terms to one side, set equal to 0, and factor into x minus 6, x plus 1, x equals 6, x equals negative 1. We must check, it's part of the problem, but negative 1 does not work, only 6 does. Here the same idea, I square both sides to eliminate the denominator first, and then I have power 3, take the cube root, and I get 4. I have to check, go back, it's working. Here we're asked to use the substitution, so I realize that if I denote this by t, this is t squared. So that's how I get this equation, t squared minus t minus 6 equals 0. I factor, I get 3 and 2, but what is t? T is x to negative 1, which is 1 over x. So then I have 3 equals 1 over x and 2 equals 1 over x. Cross multiply and get that x equals 1/3 from here and x equals 1/2 from here. Absolute value equations, I subtract 7, I get 3. Divide both sides by 4, get 3/4. And here there are two possibilities. Either the inside is positive 3/4 or the inside is negative 3/4. I move 1 to the other side. I subtract. 3/4 minus 1 is negative 1/4. Cross multiply, and you get 3, x equals 3. Same thing here. Move 1 to the other side. I get negative 7/4 on that side. Multiply both sides by 4, or negative 4. And I get 3x equals 7, and divide it 7/3. Final. I think I'm missing a page. Am I missing a page? 4 or 5? Let me see. Oh yeah, I scanned it. Got it. Okay, so here we're given a function. We're asked to plug in basically t equals 40 because t equals 0 is 1970 and 2010 is 40 years later, and I got 52%. And then we were asked when will the percentage be 49? So I replace p by 49, subtract 62. Divide both sides by negative 1.6, get this, square both sides, and I get approximately 66 years. Last section, section 1.7, linear inequality. always get rid of the fractions. Multiply this by 10, we get 3x. Multiply this by 10, we get 10. Multiply this by 10, we get 2. Multiply this by 10, we get x. I move x to this side to get 4x. I move 10 to the other side to get -8. I divide both sides by 4 to get greater than or equal to -2, and this is the solution, from -2 to infinity. Here, this is a compound inequality, so first we have to add 3 to all three sides, 6, 4x, and 22. Then we divide all three sides by 4, 6 divided by 4, 3 halves, x, 11 divided by 4, 11 halves. So x is between these two. And the last two problems, absolute value inequalities. This has to be converted like this. It's less than. And then we have to multiply by 3, multiply by the multiplicative inverse of 4/3. This times 4/3 is -24/3. -12, yes. What did I do? Yeah. Oops. Oops. -8, yes. And here, +8. Sorry. So now we're adding 1. So I get negative, yes, that's correct now. So it's -7 because I'm adding 1, and here's 9. Oops. So a -7, sorry about that, and 9. Let me double check one more time, just to make sure. -6, that's correct. Less than 6, that's correct. 4/3, so 24/3, that's -8. Again, 24/3, that's +8. I'm adding 1. So when I add 1, -8 plus 1 is -7, and this is correct. Yes, perfect. Sorry about that. I'll have to rescan this. Finally, we have an inequality that is with a symbol greater than, absolute value greater than 9, to the right of 9 or to the left of -9. Nothing in between, either to the right of 9 or to the left of -9. So I'm subtracting 3, I get 6. I multiply by -4/3. Again, I did the same thing again. Nice. So this is -8. I'm glad I'm doing this video. So -4/3, that is correct. And we multiply by negative number, so we have to switch the inequality symbol again. This is -8, correct. Okay. So then we subtract 3, yes, that's correct. Again, I did the same thing. No, this time I didn't. Okay, that one is good. Because it's -4, yes, 16. Subtract, so it's less than, we switch the inequality because we multiply by a negative number. So that's correct, but this is -8. Okay, thank you. I hope this helps.